The crown of this empire was the city that still bears his name.
Robotics seems to have begun in ancient Alexandria around about 300 BC.
In 300 BC, Alexandria was the most vibrant intellectual city in the known world.
This occurred basically because Alexandria was set up as a city where learning was very important.
And leading the field was an inventor who can claim to be called the godfather of robotics, Heron of Alexandria.
He's the big name, and it's for one simple reason. 5 of his books are still in existence.
Heron's books are evidence of an Alexandrian society that was so advanced that it became the center of learning and technological achievement throughout the known world.
Some of these early peoples were far more sophisticated than we give them credit for. They were at least as intelligent as we are now. Their mastery of philosophy, of astronomy, of what we would now call physics, was absolutely immense. So it would be dangerous for us to underestimate their capacity.
But is there evidence that the ancients actually constructed fully automated devices? The answer is yes. Recently, new discoveries dating back thousands of years reveal that the ancients did in fact have and use advanced automated machines. Worshippers visited temples with self-opening automatic doors. Audiences flocked to automated puppet theaters. And ancient texts tell of chariots flying through massive temples, seemingly on their own. By the 3rd century BC, the city had become an ancient technopark, where sophisticated machines played a part in everyday life. And at the center of it all was Heron. He was renowned for testing and demonstrating his theories and devices to produce wonder and entertainment.
He describes many different inventions that were designed to surprise and give the impression of magic.
And don't forget, he was a showman. His work was to display and make people really excited about engineering.
Alexandrian high society lost no opportunity in keeping up with the latest developments in technological innovation, even at their dinner parties. Richard Windley is an historical model maker who specializes in recreating Heron's amazing devices.
We're very fortunate in having most of the translations of Heron's treatise on pneumatics, in which he talks about air pressures, water pressures, the interaction of the two. And in his treatise he describes a number of objects which are based around these principles. This piece is number 66, and he describes it as a vessel for dispensing a measured quantity of liquid, wine usually being the favourite.
But how does the jug measure exactly how much wine to release?
Inside the vessel is a valve which is operated by this mechanism at the top, which in turn goes down to this lever which counterbalances the cup at the front.
When Richard removes the weight, the wine starts to pour. When the cup is nearly full, the balance tips and the flow of wine stops as if by magic. But how does the dispenser work?
The heart of the system is a little valve which sits inside the bottom of the vessel. The Greeks seem to favour these little conical-shaped gravity valves because they opened and closed very quickly. The little conical weight drops into the orifice of the valve when the cup is heavy enough, and this cuts off the flow of wine from the vessel to the cup.
When the weight is removed, the bar drops under gravity. This causes the connecting rod to drop, which lifts the valve, and the fluid can flow through the conical valve and out of the jug.
Now, because the cup is balanced by the weight at the rear, as soon as it reaches a predetermined point, dictated by that weight there, the cup will then drop. That arm rises, the valve drops, cuts off the flow of liquid, and so that cycle of the process is finished. It's an absolutely fascinating design, and it's probably the first real genesis of control systems that we're aware of.
But what if the guest became carried away with the ingenuity of this technological achievement, or the wine it contained? Heron had the answer.
This little invention proves that the ancient Greeks had both a sense of humour and a sense of mischief. It's called a greedy cup, and a host would present this to one of his guests who had perhaps a reputation for enjoying his cups. And what would happen is that when the chalice or calyx was partially filled with wine, it would just act as a normal cup. As soon as the guest said, no, fill it up, top up the cup,
the little siphon in the centre of the cup suddenly starts to operate, and the entire contents of the cup are dumped onto the person's lap, all over the clothes of the unsuspecting guest.
Hidden within the center column of the cup is a pipe with a bend. There's an opening to this pipe at the bottom of the cup. When the liquid in the cup reaches a level higher than the bend, air pressure forces the liquid through the tube, up and around and out of the cup. The liquid continues to flow even as the level drops below the bend because of a difference in air pressure between this height and the bottom of the tube. The liquid continues to run down the tube and all over the unsuspecting guest.
An ancient practical joke.
But Heron was interested in much more than party tricks. He used a deceptively simple invention to fantastic effect. It's called the cam. As the disc rotates, the rod moves up and down. It may sound simple, but this ingenious device translates circular motion into lateral motion. This allows a wheel to produce a push or a pull. Also, if used in reverse, a push or a pull can be converted into a circular motion. This is how the piston's movement is converted to circular motion in the camshaft of an engine. This exact principle is used in all engines, right up to the modern day. But for all of Heron's brilliance, his masterpiece was yet to come. Alexandria's modern library is a stunning architectural achievement, but the Egyptian city was a hotbed of technological innovation over 2,000 years ago, and at the cutting edge of this new wave of ingenuity was an innovator known as Heron. Many of Heron's inventions had practical applications, but he also excelled in the art of creating mechanisms for entertainment.
Mechanical technology was also used in the service of public entertainment. Ancient audiences became increasingly sophisticated, wanted more and more visual entertainment.
One of Heron's biggest challenges was to create technologically advanced entertainment systems. Arguably his most audacious idea was a theatre with no actors, only robots. In Dublin, robotics and automata designer Mick Kelly has created a replica of this incredible theatre.
First they'll see the theatre with the doors closed, and then the doors will open for them, and they'll see little men on the back of the stage making ships, and then hands will start to move and they'll hammer and they'll saw.
Backdrops fall into place, and actors and scenery move about the stage all at exactly the right time. But how did Heron ensure that each action happened in the correct order? Incredibly, all these movements are driven by a single event. When Mick pulls the release switch from a sand tube, a weight falls. This weight is attached to a camshaft that turns and pulls on strings.
And they make it revolve. And as that revolves, it pulls the other strings that are off that and winds them around it, shortening their length.
These strings are attached to pins. When these pins are released, parts of the scenery are allowed to fall under gravity. Other pins release secondary weights that fall and pull extra strings, which move the other features around the stage. Heron's theatre is a highly complex automatic machine. Even more amazing is that it is programmable.
Those strings are different lengths, and that determines when a mechanism is going to operate. So to change the length of a string will effectively program to do something else.
So what looks like a simple toy is actually one of the first pieces of automated programmable machinery ever created. Heron relied on two principles for his automated devices. The first, used in machines such as the theatre, relied on weighted moving parts, ropes and wires, and cams. But Heron innovated a second breakthrough in automation, the world's first hydraulic systems.
One of Heron's favourite mechanisms appeared to be a device whereby air pressure is produced by water moving from one vessel into another. As the water runs into the vessel, the air is compressed and has to move somewhere, so it's usually piped to possibly a sound-producing or movement-producing device.
Today, this technology is known as pneumatics.
Pneumatics is all about the way in which air and gas move and how air and gas can be used to move things.